Alright guys, welcome back to another channel episode. Remember, this is a channel where we talk all about how you don't need to be a CEO in order to have some impact on the world. And if you've been following this series closely, you know that we're getting our Tensorflow certification. We're trying to do so in 2 months, and in fact, this is actually going to be the last episode of the series because we are finally done studying for the test, the exam. Now, the exam, I'm going to be taking it next week, which means that the 2 months is up. I've been studying for the last 2 months. I'm going to go more into that in depth later on. But in particular, right now, I want to talk about what a journey it's been and how excited I am to finally get the course done and to kind of get that feedback from basically the world, the certification from Google, letting me know that the work I've been doing has actually been working and paying off, and that I am now certified according to Google to work with Tensorflow to do machine learning with the latest tools that they have available, Tensorflow, I think 2.4 or something like that. So super excited for that. I will do a video talking all about overall my thoughts and how I've studied and just, more in general, note-taking strategies, learning strategies, and how the exam was. Everything that I can share about the exam, I will. But for now, let's just go into what I usually do in these weekly videos where I just give an update on what I've been learning and everything that I kind of took notes on and everything that I learned just for this week. Now, this week, I'm going to show you, I spent 2 days learning about time series and a lot on doing RNNs and LSTMs and mixing convolutional neural nets with LSTMs. Now, before I talk any more about that, I'm just going to pull up my notes to show you because it's best to do it that way. So here we go. Let's get my notes. Alright, so as always, got my iPad with me and I'm going to show you guys the notes I've been taking. Right now, I'm going to show you guys my log. And as you can see, the log, we are all the way at the bottom. You can see April 20th, I did week 3 on TensorFlow course. And then on April 21st, I did week 4. Now, right above that, you can see how I took a break. And you guys might have realized that this week, I'm posting this video, but last week, I missed that weekly update. And the one before that, I actually did do on my week 2 of TensorFlow course. So I took a week break off because I had a lot of personal things going on at the time. And so I was forced to take the week off. It's completely fine. I'm not going to be counting that towards the 2 months because I didn't do any work on TensorFlow. So you can still do TensorFlow in 2 months. Now again, I'm going to talk all about this in kind of an update video where I talk about my general impressions of doing this and what I would change and things like that. But in general, so like I mentioned, I had the family break that I took. It was around a week or two. And then on April 20th, I did week 3 on TensorFlow. And then on April 21st, I did week 4. The rest of the week was filled with personal things as well as a little bit of job searching, but mostly personal things. April has been a kind of a difficult month for me, just with family things. But nevertheless, I was able to find some time in order to get my stuff done and stay on track. Now, a little bit about what I'm going to do next is today I was going to do some PyCharm to make sure that I have everything ready and it works for the exam so that I can take it after the weekend is done. So let's go on to my notes. Whoops. By the way, guys, a lot of you guys have been saying that I should put up my notes down below, and so I've done that. If you check down below, you can see my website, and in my website, if you click, you'll be taken to a place where you can kind of see my past projects, a little bit about me, but you could also click on the Learning TensorFlow, and once you click that, you'll be able to see my log and where I am, and then right below, just as I clicked, you have a link that sends you to my Intro to TensorFlow notes. So it's this exact page you're going to see, and you're going to be able to look, to copy, to study along, and just if you have any questions, just put a comment below. Anything else I should do to help you guys out, I'm free to do it. So let's go to week 3. So week 3 was about RNNs and LSTMs, like I had mentioned. Also, bonus, they taught us all about Lambda layers and using Lambda layers in TensorFlow. So let's open that. So yeah, so a little bit, we had to learn first a little bit of what RNNs are, and what RNNs are is basically it's a neural network that has a kind of memory, past memory. And this picture shows it the best in my opinion. You can see the cells, and you see that there's an X that goes in, it goes through the cell, and then outside you get a Y hat, right? But also you get an HO in that example, and then that HO becomes H1, H2. And so basically what that is, that's a copy of the Y, a hat, that gets brought along to the next neural network cell to kind of remember what happened in the past. Now, of course, as time goes by, you start to forget the things that happened long ago. So that's the difference between RNNs and LSTMs, but we'll learn about LSTMs later on. So that's that example. It's a better visual here on how it's done. And then yeah, so really it's kind of cool because with RNNs you kind of get two things you can do. You can do a sequence to vector RNN, which is you're outputting just that one Y hat at the very end of like your predicted value. But you can also do a really cool thing where you can do, it's called return sequences. And so when you do a return sequence, that's a sequence to sequence RNN. And what that allows you to do in TensorFlow, it's just I can show you actually right here in this code. You can see on the fourth line how it says Keras layers simple RNN return sequences equals true. So what that does is that it doesn't only return the Y hat, the predicted value, but it also returns the whole entire sequence, like kind of memorized all the Y's and all the H's in order to be able to, sorry, H's. Yeah, H's. To be able to kind of then move on to the next RNN. So basically here what you're able to do with return sequences equals true, you can layer RNNs on top of each other and keep them going instead of having them end at one point. So that's what that's called a sequence to sequence RNN, but we also have the sequence to vector. Cool, so that we learned all about that. That's really cool. Very important, because most of the time I find myself using more than just one RNN or LSTMs. You use the same syntax, but that's what you need to do if you want to stack RNNs on top of each other. So that was something really cool that I learned. Later on, I also learned all about Lambda layers. Lambda layers is really cool because if you don't know what a Lambda function is, it's a kind of a temporary function that you can write. It doesn't need to be defined, so it doesn't need to have a name. You don't have to write def my function equals, sorry, not equals, semicolon, no, colon. You don't need to have that. You don't have to have a definition or return statement. You can just do lambda x colon and then have your function right there in one line. Very, very useful, used a lot in Python, and in fact you can use them in TensorFlow in your model as well. And this is really cool for when you need to do some changes to your data on the fly. So usually you do some pre-processing, you run it through the model, you get an output, and then that's done. But really what you can also do with Lambda layers is you can add a layer to your model that's a function, whatever arbitrary function you want. Like let's say you want to make all x's times 10, right? You can do that within the model while it's running, and that's very, very useful for in some cases. In particular, when we're dealing with time series, it really helps to be able to sometimes expand the dimensions of something inside the model, fix window sizes and things like that inside the model. So using a Lambda layer is super useful. I'm super glad that they added that as a functionality in TensorFlow, and also really excited to now know how to use that for when I need to. And so here you have a perfect example highlighted in red, how you use the lambda layer to use tf.expand dimensions to add another dimension to the time series. And then we also learned something, oh my god, we learned a lot this week that's very exciting, because we also then learned all about using callbacks to find the optimal learning rate. I don't know if I had learned this before. I feel like I did, but it's, yeah, I think I did. I think I didn't include it here because I learned it all about it before. But basically, you can use a callback. I'm forgetting the syntax, but it's basically like, you give it a name, you do TensorFlow callbacks, and you put that you want to basically run every time the model runs, you want to have a new learning rate. And so you basically want to test the learning rates and see which one you get the better result from. And then after you run the model, let's say for like 100 epochs, trying to see with a lot of basically a different range of learning rates, you then check to see at what point the learning rate kind of stops being helpful or gets too much or too little, and you find that perfect place, and you use that to then, if you have an example, I'll have an example later on actually in week 4, but basically what's important to note here is that you can find the optimum learning rate using callbacks. You just set that up, and then you print the graph, check where is the best optimum learning rate, you set that, and then you run the model for the full amount of epochs you want with just that one. Instead of using callbacks again and switching through multiple learning rates, you choose that one, and you know that you're getting the best, most optimum learning rate from your model. So that's awesome. Also, we learned about the Huber loss function. It's a different loss function. I can show you guys actually right here. That's what it looks like. It's very useful for time series. It's just another loss function for our knowledge. Then we did some examples, but yeah, then that was RNNs, lambda layers, and optimizing learning rates. That's a lot of things already, but the week kept on giving. We learned about LSTMs, long short-term memory. So here it's very similar to the RNNs, where you have an X and a Y, but instead of having an H, you have a cell state. And what that allows you to have is one value that goes across all the cells for a longer period of time. So you have, not only do you have a short-term memory, but you also have a long-term memory. And so what this allows you to do is not only remember just what the last value was, but also the value 30 places ago or 100 places ago, right? And so I have here that the cell state can actually be bidirectional or just one directional. So you can have it go forwards, but you can also have it go backwards. And that's very helpful. A lot of the times you'll know when that is, when it'll be more helpful. You can always try to see in your model if it's helpful or not, but a lot of the time doing something bidirectional will actually maybe increase your training, but not really increase your validation. So that's one thing to note, but you can actually make it bidirectional. You just have to set it as in the layer when you call the LSTM, you just set bidirectional equals true. And so yeah, so in the end of the assessment, what we basically did is that we had some kind of a noisy man-made time series data set, and we did an RNNs on one and we did LSTMs on another, and we saw that actually the LSTMs did a little bit better than the RNNs. And yeah, that was it. That was week 3. It was very jam-packed actually, really long, but it had a lot of information that I'm very happy I learned, especially for time series. I gotta admit that after this, even though I had seen it before, the learning rate, I had a little bit of trouble trying to actually get it to... I had a little bit of trouble trying to choose the right learning rate. I didn't know if I should choose right when it's like the best, or like right before or right after, because there's a point in time as the learning rate, as the loss keeps going down and down and down, that it kind of flattens out and then gets like really noisy. I was trying to see like what the best point to choose, and honestly, what I've basically discovered is that you kind of want it to be like right before the noise, even if it's just a little bit even more before the noise, but the better, so that you get kind of like a smooth kind of loss function. So let's go over week 4 actually. Cool. So week 4 was all about convolutions. It's spelled wrong. On top of the LSTMs. So, and we also use sunspot data. So we just described LSTM, so now we're going to use them more in depth, and we're also going to add another layer on top of that, which is our usual convolutional neural networks. If you need to know anything about convolutional neural networks, I have a lot of videos where I talked about that before, specifically towards the beginning of my goal of getting TensorFlow certified. So just see those. But this week, we went one step further. We learned how to mix the two models, the two layers together. And it was really, really interesting because what you're doing with a convolution is you're adding filters on top of the data that then the LSTM tries to learn. Amazing. And so you are able to do this by inputting the amount of filters you want, but then also the window size that you want the filters to multiply by. So if you set it by a 5, not by a 5, right? That's the number of windows it would multiply at the values of that window. It's very similar to how the image convolutions are, where you have kind of a section and you multiply it by values on that section, that filter. This is very similar. You kind of like you get the window of, even though the window that you're passing through the model is 30, you would only get 5, and then you would multiply it by the filter, and then you get the next 5 and you multiply it by the filter. That's kind of how it works. And so yeah, so a lot of stuff happened while we were doing this. We got low MAE values, but there was a lot of overfitting, so that's not that good. So we might have to, we had to tweak some parameters. We weren't able to go with the parameters of the LSTM that we used on the other data set with this data set, the sunspot models data set, because it wasn't optimized for that. And so in fact, we actually learned a lot about how to optimize the hyperparameters, and I'm going to talk about that. But right now I want to talk about how the data was set up, because the data was actually what we used information from the data in order to optimize our hyperparameters. So, for example, we know our data set is sunspot data, and we know that they say it's around 11 years. It has a kind of a seasonality of 11 years, and some even say it's actually like 22 years. And so knowing that, we were like, hey, what if we set the batch size to be that size, or we set, the window to be a bigger size and things like that. And so we decided to change that. And actually, we learned a lot about, first, that's what we did. First, we tried different batch sizes to see if that helps. And then we tried, sorry, so I don't have it here, I think. Oh, I do it, sorry. I just had to scroll down a little bit more. So down here, when we first did the batch size, it kind of helped a little bit. But then we also learned we're getting a lot of noise in our loss function, and we're like, okay, this is usually when you get a little bit of noise in your loss function towards the end, that means there's something wrong, and you can fix that using the hyperparameters. And so that's what we did. It was like kind of really like, everywhere, very noisy. And as you see in this graph, we were able to get the training loss to go from that kind of super noisy, like everywhere, to a very regular wave, as you see on that right graph right there. The right graph is just a zoomed in version of the training loss on the left. And as you can see there, it's kind of a little bit more regular, less noisy, which means that our updates that we did to the model actually helped. So that's a kind of a benefit. Now, it still looks like it's, going everywhere, but because it's a smooth wave, I learned that actually that means that we are getting in a better direction. that's something new that I learned this week too, is that when you see the loss being that messy, that noisy, there's some things you can definitely tune about your model. So one of the things I did was we changed the batch size to 256, which I think was 11 months. I'm not sure about that. And then we trained it for more epochs. And so after we did that with the batch size, we decided to change another hyperparameter, and we looked at the training size of our data, and it was 3K or 3,000 points, right? So after multiple years, I'm not sure how many years, but I think it was like 20 something years or more. And so we decided to change all our numbers in our model. So the numbers, the hyperparameters would be like, batch size or window size and filter size and how many neurons in the dense layers. All those numbers, we changed them to multiples of 3K, 3,000. And so, because before we usually use powers of 2, like 32, 64, 126, 100, yeah. And so they changed it everything from like 64 to 60. And when we did that, the loss function actually got even more regular, which is awesome. But it didn't really help the MAE that much, just a little bit. But it's really cool to note that things like that actually matter. To me, I always saw models be in multiples of 2. So now knowing that I can now think about the data and the size of the data and what multiples it's in and how it would be divided in the model to better improve my model and the math behind my model. So that's very very crucial, and I'm so glad I learned that in this course. And I think that was kind of it for the week. Yeah, so that was a lot as well. This is a very jam-packed video of a lot of things I learned. I learned even more things just playing around, specifically getting the time series into Windows. I'm still having a bunch of trouble doing that the right way the first time. It takes a couple of tries before I'm able to get it into the right dimensions to go into the model. But I had a lot of fun learning time series, specifically working with actual data, the sunspot data, but also working with RNNs, LSTMs, and convolutions with LSTMs, and seeing how that messes with everything. Callbacks, Lambda Layers, all of that was a lot of fun. So that's all for this week, actually. Next video is the video that I'm going to be talking all about whether or not I got my TensorFlow certification or not. So stay tuned for that video because it's going to be awesome. And I will probably also talk in that video about what sources really worked and which sources didn't work, what part of my notes there's more helpful than other parts of my notes, and all that. And remember, if you guys want to learn more about my notes or just go over it, read more deeply, I know I just go quick through it, you can go to my website where I have all my notes there and a bunch of other resources too. So yep, that's all for this video. Thanks for watching, and see you next time. Peace.